Hi, I'm Marty Hulce, a professor in the Department of Chemistry and Biochemistry. Welcome to our virtual table for the CURAS 2021 Fair for Research and Scholarship. I'd like to tell you today about some undergraduate opportunities in research in my department. To do that, I will tell you a little bit about what is research in chemistry and biochemistry and why you should do it. I'll tell you a little bit about what's going on in Creighton. There's a lot. And should you participate in research at Creighton in chemistry and biochemistry, what sort of expectations are there? What can you get out of it, and where can you find more information? So an important question is, what's research? Well, scientific research is an investigation or an examination that uses the scientific method. And it can do many things. It can, for instance, discover new information or interpret new information. That's called basic research. An example here I have for you is the synthesis of one of the isotopes of livermorium in 2000, a brand new element for the periodic table. So new still today that its chemical characterization is still in progress. Well, you can also take new information and known information, and you can apply it to problems in society and science. That's called applied research. And an example I could show you here with regards to chemistry is one that's actually a problem. If you see this molecule that is on the left of the screen, that's pseudoephedrine. And pseudoephedrine can be converted into methamphetamine using a well-known chemical reaction. That chemical reaction requires a metal like lithium or sodium and liquid ammonia, which is very common as fertilizer here in our part of the world. Well, if you take that liquid ammonia and you treat it with a little bit of a salt, calcium nitrate, it poisons the liquid ammonia, so it can no longer be used to make methamphetamine from pseudoephedrine. And I'm just showing you here how that's true. Up here in the upper right, you see a photograph of liquid ammonia that doesn't have any of the salt in it. And it's kind of this dark purpley color. You can't see through it. If you add a little bit of that salt, you see how the lower picture shows how the color of the liquid ammonia changes. It becomes kind of clear and yellow looking. Well, only that dark purple opaque liquid ammonia with the lithium metal in it is useful for this reaction that creates methamphetamine. Once the ammonia has been poisoned with calcium nitrate, it can no longer be used for this reaction. It's still perfectly good as a fertilizer, however, and it stops people from stealing liquid ammonia at tank farms for making methamphetamine. Applied research. Now, there are even other kinds of research we could talk about. Some research is integrative. It takes data that's been produced by other and creates something new about it. For instance, I've shown you a map of the percent iron in the soils of Mars. The percent iron map was created by many individual explorations of the Martian surface and then assembled as this comprehensive map, explaining to us why iron, which is rust, the red planet, Mars. We can also take data and we can distribute it after we've organized it for the information of others. And an example would be writing a book, like a textbook. And I've shown you here a third edition of a famous organic chemistry textbook called Morrison and Boyd, and how it's been revised over the year through distributive research to its current 7th edition. Well, if you're going to do some research, there might be some sort of reason why you might want to do it, and different motivations for different people, right? So basic research, if we were to go way back to the beginning of the 19th century, a famous chemist named Michael Faraday, inventor of the electric motor, among other things, in describing his basic research of the discovery and properties of fluorine, bromine, chlorine, and iodine, the halogens, said, hey, for those of people who are saying, you know, you're generating this new information, what good is it? Why aren't you're just wasting your time. Well, Dr. Benjamin Franklin says, well, what is the use of an infant? You know, babies are hard to bring up. They're hard to bring into the world, but they have great value as adults when they mature. So new information can be very valuable after it's been discovered. Now, research also enhances teaching. That's why many of us do it in my department. It contributes to the betterment of society, which is certainly one of Creighton's fundamental missions. And by discovering new knowledge, it helps humankind's future prospects. It happens to be a pursuit of truth, and if you believe that the truth shall set you free, then you should do some research, I suppose. And you could also consider it to be an act of worship, a way to better know the mind of God. For example, I've shown you a rather old text before modern chemistry and biochemistry. This is from the age of alchemy. It's entitled Alchemista Christianus, where the textbook author describes the relationship of transmuting elements to being similar to that of transforming the elements of the Eucharist into the blood and body of Christ. Now, doing research is also fun, okay? That's a major reason why I do it. I enjoy doing the action of research. So let's talk a little bit about what's chemistry, what's biochemistry. Well, chemistry deals with the composition, the properties, and the behavior of stuff, matter, okay? And we consider it to be the central science connecting biology, okay, animate matter, physics, okay, which moves matter around through laws of motion and energy transfer, and geology, the stuff that we stand on, the central science. Biochemistry, similarly, is the central science that explores chemistry as it relates to living organism. So it is the interface between biology and chemistry. It uses chemical principles to better solve biological problems, and questions we have is how biology works in nature. What's going on at Creighton in biochemistry and chemistry? Well, historically, I can tell you that the Department of Chemistry was the first scientific department to be created at Creighton. And it was the first one to have its own building. I can show you this map, which was written by Father Joseph Riggy. The bottom of the map is California Street. And you can see a little square down towards the bottom that says Chem Lab. That Chem Lab was constructed such that if we envisioned it on campus today, its northeast corner would actually touch the southwest corner of St. John's. Well, it's not there today anymore, is it? Okay, but it did allow Father Riggy to produce some of our first scientific publications at the university in the Scientific American. Today, there's all sorts of chemistry and biochemistry going on at Creighton in support of biomedical research, pure chemistry and biochemistry, and all sorts of integrative programs across many disciplines. In the College of Arts and Sciences, you can see a list of departments, all that use chemistry and biochemistry in its daily research endeavors. Similarly, there are departments in the School of Medicine, the School of Dentistry, and the School of Pharmacy and Allied Health Professions that all are doing chemical and biochemical research. They all span many topics. The topics that share these three measures. We manipulate matter by measuring it, making it, or modeling it. That's what chemists and biochemists do. They take a peek at matter and they measure it, make it, and model it. Now, how they do that, we can talk about whether they're more of a measurer, more of a modeler, more of a maker, and that puts us into different sub-disciplines. For instance, analytical chemists on the top left, they measure matter. How much? How clean? How pure? Okay, how can they be distinguished between one another? We also have, for instance, down towards the bottom of that left column, forensic chemistry, which is just simply chemistry or biochemistry applied to law. And toxicology in our second column, which talks about adverse and maybe beneficial effects of chemicals and biochemicals on organisms, how do poisons work, for instance. So we span a wide array of topics in the manipulation, the measuring, the making, and the manipulation of matter. I'm an organic chemist, and I can tell you that our specific laboratory is mostly a maker of matter. We investigate how you can knit molecules together and create new architectures from old architectures. So we have a variety of these sorts of research programs going on in our laboratory, which share the same feature of taking simple molecules and making rich, complex molecules with specific architectures associated with them. Other people use chemistry and biochemistry in other ways. If you were to work in a chemistry or biochemistry laboratory, what will we expect of you? Well, you know, for specific expectations, you should talk to a faculty member, but generally I can tell you that you would register for a course, either a Chem 497, 496, 497, 498. It kind of depends whether you're a major or not and where you are in your career. For each credit hour of laboratory that you register, you should probably plan on spending 3 or more hours engaged in research. Were you to be a major in my department, you would also end up taking Chem 499, which is a biweekly departmental seminar program. If you're not a chem major, you could still attend those seminars. We have them every other week. We Zoom them, and they're very interesting and a lot of fun. While you're working in a laboratory, you would also maintain a laboratory notebook and write progress reports and ultimately a final research report on what you have done. While you're doing this research, you would inform yourself by reading the original research literature, chemical literature and biochemical literature, and you would want to share what you've learned with others in a public setting. Finally, we'd hope that generally you would enjoy the experience of doing research. Okay? But again, you should talk to a specific faculty member because different people have different expectations, but these would be the general ones. If you do research, what would you expect to get out of it? Well, you could present posters both in person and virtually in venues such as we're having today, okay? The CURAS Research and Scholarship Fair, or later in the spring semester at Creighton's St. Albert's Day poster session celebrating University Research Day, or more regionally at regional meetings of certain scientific societies, and also, for instance, the Nebraska Academy of Sciences. Some students will also give oral presentations of their work, much like I'm doing an oral presentation of research that's going on here in biochemistry and chemistry at Creighton to you. You could give a research presentation of what you've done, both in person, at national meetings, at international meetings, okay, or smaller meetings at Creighton or the state or the region. You may also find that you could publish something in a peer-reviewed journal. So I've shown you some outcomes from my department. Okay, students that have been highlighted here in this blue color are all undergraduate students that have been working in various research laboratories. So you can also get peer-reviewed publications from your work. Very nice for your CV or resume, should you be pursuing professional studies or graduate studies. And I'd be remiss if I didn't say one of the outcomes of doing research with others is long-lasting relationships with those others, between the colleagues in your labs and also with your laboratory research advisor. So you can see down at the lower left, that's Dr. Julianne Sokup with members of her research group from maybe 2 years ago. And they're all smiling and they're all happy, aren't they? Because they're all friends and they've enjoyed this experience together. If you need more information, I can say, check out research descriptions of any faculty member on their departmental web pages, okay? So any one of those, for example, okay? You could also contact CURAS, look at their website, or get in touch with a CURAS ambassador. They would love to tell you more about research that's going on at Creighton University. Maybe you'll stop by later at our virtual table and we could talk to you about that as well, where we have a PDF document that talks about individual faculty research and interests in my department. So thanks very much for stopping by today. Have a great time at the research fair, and I hope to see you at my virtual table through Zoom. Bye now.